And I believe this one we spent long time to finish, each x and y, z. So if you go back to the video that I recorded in the last session, I literally show you how to find out each partial differentiation. So go back. I want to practice with the following question right there below B. So let's do letter B. Okay, so I need a space. So we have a g function, and then it is sine x second y minus z plus cosine x second minus yz. So we're gonna do step by step because we have to find out all three xyz partial differentiation. So I'm gonna start from focusing on x. In other words, I'm taking differentiation with respect to x variable. It implies that y and z are going to be a constant. So we have a function derivative dx, and then we have a big function sine x second y minus z cosine x second yz. So that's what we are doing. We are taking the differentiation with respect to d. So you're looking at only the x variable, and whatever others are going to be considered as a constant. Step one, we need to take a look at this. Is when you look at this, the sine x second y minus d, you see the two structure going on. Do you see that? One is a sine function, and another one, x second y minus d, has been subbed there. So I already see that you have to apply a chain rule. Don't you feel it? And same thing, cosine. One function is a cosine function itself, and then x second minus yz has been subbed there. So definitely each term, you're gonna apply a chain rule. So far, so good. So let's take a chain rule step by step. The sine will be what? If you take the derivative of the sine, be careful, it's gonna be positive cosine, not negative. So you can refer the differentiation table. So the outside, cosine x second y minus d. And we have to take a look at the inside one more time. So if I highlight it, this is the outside. This is the inside chain rule for the first term. And I'm keep going. The second term, we have a cosine x second minus yz. You always need to check the structure. So cosine, if you take the derivative, what happened? It's a sine, but it's a positive or negative. It is going to be negative. So cosine, I'm going to just write negative sine x second minus yz. And you have to take another differentiation inside x second yz. So again, this is the outside. This is the inside. So we have two terms going on. All right, time to simplify. So we have to do differentiation these two. So what is that? First, cosine x second y minus z. As I mentioned, whatever other variable, these are constant. So when you take the derivative of the constant, that's going to be 0. And also we have x second power right there. So if you take the derivative, what happened? This is going to be 2 xy, and then z is going to be 0. Are you following what's happening here? So many people make a mistake. Y is a constant. So you can consider that's a 2, 3, 4, whatever the number. So, and then we have a second x to the second power. So taking the derivative with respect to x, that's going to be 2x, and you're going to keep the y because that is a constant. But here we don't have an x, it's just a constant only. So that's going to be 0. So that's the first term's outcome. And I have negative sine x second minus yz. Same thing, what happened? This is a constant, will be 0. And we have only 2x right there. So you can organize the order. Always the number is the first. So 2xy cosine x second y minus z minus 2x sine x second minus yz. That's your f of f sub, we took the partial derivative with respect to x of this three variable. So that's one answer. Okay, so this is the work of partial derivative that you're going to show me your work. Okay, I'm not done yet. As you know, we know, we need to continue. Sorry, what happened? So I'm going to minimize a little bit. So we are actually going to the second one, f, y, x, y, z. We are taking partial derivative with respect to y. So what happened? D, dy, same function, sine x second y minus z, cosine x second yz. Now you guys know what to do. I see the same structure of the chain rule. So this one, keep the outside because y is a part of the sine. So what we're going to do, it's going to be cosine anyway, x second y minus z. Am I right? And then what happened? D over dy inside. And then the next one, that's going to be negative sine x second minus yz, and d dy inside, you're taking the derivative. Are you okay with that? So if I highlight it one more time, you know what's going on outside. This is the outside. We already took the differentiation. And then this is going to be the inside the chain rule. All right, let's continue. So this is going to be, you have to take the derivative. So cosine x second y minus z. What happened? So now x and z constant. Am I correct? So what are you guys going to do? X second y minus z is going to be 0 because there's no y. But x second y, this is something you have to think about it. X second is a constant, so they're not going to be disappear. It's still there. So now only x second remaining, because y, when you take the derivative, it's going to be 1. Minus sine x second minus yz. And then where's y? Right there. So x second in this time will be 0, because a constant will be 0 when you take the derivative. And now we have only negative z. So now wrap it up. I'm going to bring x second cosine x second y minus z, double negative change to positive z, sine x second yz. So that's the f partial derivative with respect to y of the three variable. Are you guys okay so far, so good? So this is not something new. We already talked about it. I'm practicing one more time because you never know what kind of function you're going to have. So we have to practice with different function. Sometimes you will observe chain rule, product rule, quotient rule. It's the same thing. The calculus 3 is literally accumulated from calculus 1 and 2. We are using the similar technique, just expanding the variable. Okay? So let's do one more, the last one, the partial derivative with respect to z. All right, let's go. So the last one, you know what? For your information, I will just make a separate. So that's x and y and z. All right, let's go to z, partial derivative of x, y, z. So d over dz, what is the function? Sine x second y, z, cosine x second y, z. So everywhere I see the z, so we can take the same chain rule outside and inside. So the outside, that is going to be cosine x second y minus z. And then inside, x second y minus z. Again, x, y is a constant, they are constant in this time. Minus sine x second y z. D over dz, x second y z. So now you see the better structure, what we are doing outside. We took the differentiation inside. All right. So what happened? Cosine x second y minus z. What happened? Somebody can tell me what you say. You are taking differentiation with z in this time. So x second y will be what? That's a constant, it will be 0. So we have only negative z, that's gonna be -1. Are you following? Minus sine x second my yz. Same thing, x second is a 0, and we have a minus y as a constant, so z will be 0. We still have a negative y. So I'm gonna change the order, minus cosine x second y minus z, double negative, change positive. So this is what you're gonna show me the work. So that's the partial derivative with respect to z. Okay, so same concept is applying. If you have this function, check it out how we solved the letter A. We literally did each x, y, z partial derivative. Check it out, our lecture video. Okay, so we are keep on going the next practice. I'm gonna have a moment so you can take a look at it. If you got this idea, I love to see your thumbs up. This is not something new, right? This is not something new. We literally did this one. I'm helping you to review one more time. So if you feel like this is something new, I strongly recommend you to watch last Thursday video, okay? We just introduced 4.3 last time. All right, so now we're gonna keep building the next idea. So let me go down slowly. So this is something I really wanna focus on today. Second order, dun, 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 dun. So far we took one partial derivative. So do you remember in calculus 1, f prime means you are taking one differentiation, but f double prime, whatever you took the derivative of the function, you take one more time of the function. It's a double differentiation basically, right? So same thing happening with the partial derivative. So what does it mean with the 3 variable or 2 variable? So let me give you the example. So let's say we have a function f of xy. This is a function of 2 variable. I want to take the second partial derivative. So first of all, don't look at this part because this is like a little bit awkward. So I think I have a little type error. So actually I'm going to change it. This is xx. No. Okay, let me change that. xy. This is yz. So this is xx, xy. Oh, sorry, my bad. This is yy. So we have 4 cases because we are taking double partial derivative. So we have only, so far we did f of x, xy, right? Fy, xy. But what I'm going to do, if you have to take one more differentiation, watch me. This one has 2 possible. fx, fx. The next 3, you can take the x differentiation one more time. You can take the derivative with respect to y one more time. So from here, you can have a following 2 possible outcomes, like a tree. And then same thing, for the second case, you have a next 2 possible. What is it? So we have a fy, you already got it. But now you have, we have xy, xy. What happened? Now you can have either yx or yy. So now, by taking second partial derivative from here, you have 4 different cases. One is xx, yy, xy, and yx. Does it make sense? So that's actually what we are going to do. So mathematically, same thing. We have, dx. We already took the partial derivative with respect to x. We're going to take one more time partial derivative with respect to x. So we have x second, which means xx you're going to get. Second one, y. So it's going to be y second, y. That's what they mean. Or you took already y, and the next one is x. So yx. Actually, this one I have to change the order. This is not the beautiful order. So this one should be yx, this one should be xy. So this one will be yx. You took the y first and xy later. But anyway, you will see what's the difference later. So basically we have 4 different cases. XX, YX, YX, or sorry, XX, YY, YX, XY. And then I will show you each cases. Okay, so let's take a look at the example. So I have a little bit of typo, sorry about that. I don't know why I create that way. So this one, just change that if you want. So you took y first, then x. You took x first, then y. Okay, so that's gonna be better. All right, so anyway, that's what is going on. So that should be x as well. So let me show you the example. And the one theorem, I'm gonna prove that, you know what? That's a really, really interesting fact. No matter what, if you have a second order of xy, second order of yx, so the difference is you took the differentiation with x first, then y first x, the outcome is always equal. So always, whatever the function, this theorem gonna apply. We call this is Clairaut. My pronunciation might be a little bit awkward, but Clairaut theorem. This is the theorem f of xy equal to fyx. So just remember, we are not only looking for xy partial derivative. You can take the second partial derivative, and then you have 4 different cases, and always xy, yx partial double derivative will be equal to each other. So this is the important theorem. We also say this is a mixed partial theorem. So usually when I learned this concept long time ago, this is a mixed partial theorem. And then especially xy and yx partial double second derivative are equal to each other. So let me prove that idea. And now you might be wondering, oh, once I take the partial derivative, should I have to do again one more time? Yes, so I will show you how it works. I think I have an example. So let me go down slowly. Here we go. This is a great example. So, okay, we have just regular functions. So if you have an original function, to avoid confusion, just put 0. So this means that they haven't taken any differentiation. That's the mathematical symbol F0. So we see what's going on. So this is a given function of 2 variables. Step 1, we need to find out each f of xy. Yeah. And then I'm going to create the 4 different cases, right? So first of all, we're going to take the first partial derivative. Are you guys okay with that? So we need to just practice it. D over dx, x to the second, y to the 5th, 3xy. Again, y will be constant, and then we are taking the differentiation with respect to x. So this is going to be 2x, and y to the 5th is still there because that's a constant. Plus, and it's going to be 3y. Are you okay with that? So this is f partial derivative with x. Second, we need to find out y. So d over dy, same function. What happened? Now x is a constant, so 5, y to the 4, x to the 2nd, still there. And then plus 3, x will be there. So that's each partial derivative with each x and y. Now we are going to take the double second derivative from here. Step 1, we need to find out which one you want to do first, fxx. So that means d over dx to the 2nd, correct? But if you're confused, don't write that way. Just take 1, d over dx. What happened? You're going to bring the x, right? This is the x. We are taking f of x. We are taking the partial derivative of the f of x with respect to x one more time. So 2xy to the 5th, 3y. That's what we are doing. So let me make a big bracket. Keep on going. Are you following? So this is we already took x, and this is the dx. So we are doing xx. So that's what's going on. All right, so this one is a little bit tricky. So I'm gonna show you first, because we are not consider whatever y is a constant in this like we are not doing the similar work. What I'm going to do here, a little bit work. So we are taking dx. So 2x is okay. This y to the fifth is bugging me, correct? So what I'm gonna do, I'm gonna say a equal to y to the fifth. I'm gonna create another variable, and then 3y, this y, we're gonna say it is b. So what happened is, it means now we are going to d over dx, and then we are going to say 2xa plus 3b. Something happened like that. So now we are going to take the derivative with respect to x, because this is a second derivative. So we are making a little bit of a distinction from the first partial derivative. So highlighted whatever, your constant, y to the fifth is a constant. Y is a constant because we are taking the differentiation with respect to x. So we're gonna just say that is a, that is b. So we have now 2xa plus 3b. So now what happened? When you take the differentiation, let's see what happened. 2a will be remaining, and then 3a will be 0. Am I correct? So now we are going back to substitute what the a was. So now sub by x. We know a equal to y to the fifth. So now it is actually same to 2y to the fifth. So that's the answer. F double second partial derivative, it is a 2y to the fifth. So that's the conclusion. This is how we are taking the second derivative. Nothing is special. We're just creating another a and b variable because that help us to take the differentiation much easier. Okay, so I'm gonna make a little bit smaller. So that's what's happening. I'm gonna just, okay. So same thing, let me go to the YY. Okay, let's go to the YY. I'm gonna choose the same color, F, YY. So that means a D, DY. We have a 5y to the 4, x to the second plus 3x. Are you following? So same thing, we are taking the derivative with respect to y this time. So x is like a constant. So I'm gonna say x to the second, now that's gonna be my a, or you can say that's a c. So this is going to be the c, and then you say this is going to be the d. So now I'm gonna say c equal to x to the second, d equal to x. So keep writing, d over dx, what happened? 5y to the 4c plus 3d. Now it helps us, this model help us to take the differentiation is easier. So what happened? We are oh, my bad, this one should be y, very bad. So this one, we are taking the dy. So now 5y to the 4, what's going on? That is going to be 4 times a 4, 5 times a 4, that is a 20, right? Y to the third, and you're gonna keep the c because that's a constant, but 3d, that's a constant, will be 0. Am I correct? So now what happened? We are going back to the x or y variable. So c was x to the second. So therefore, fyy, we got 20 y to the third, x to the second, but you can change the order, 20, x to the second, y to the third. So that's the fyy. This is the double partial derivative. So we got those two so far. Are you guys okay with that? All right. So the third and fourth, xy and yz. So let me actually make a space, 2 space. This is, let's say we're gonna do xy here. Here we're gonna do yx. So step 1, so it means you already took the differentiation, partial differentiation with respect to x. So x is here, 2xy to the 5th plus 3y. From here, you are going to take the differentiation dy. Are you following? So this is an fxy. Am I correct? So this is already fy and then fx, my bad, fx, and we are taking second partial derivative with respect to y. So this is xy. So now in this time, which one are you going to do? Again, you can create another variable. So this is y, 2x. 2x is going to be the a, and then 3y, that's okay, right? Because we have a y. So that's going to be a equal to 2x. So what happened? If you take the derivative, d dy, I'm going to take the derivative. So that's going to be a y to the 5th plus 3y. So now you're taking the derivative that is going to be, I have a little bit of type error. Sorry about that. So let me just go back. Because I just need to clarify one thing. Here, only x variable, we don't include the 2, just my bad. So whenever you have a number, we do not include the constant, right? So I had a, I made a mistake, I include 2, so I'm gonna rewrite it. So this one, let's say a equal to x, right? That's better. Now from here, d over dx, dy, we have a 2a y to the 5th plus 3y. Yep, this is clear. So now this is going to be 10, 2 times 5, 10a y to the 4, and then 3y, it is going to be 3. Are you guys okay? And I'm going to plug in back because a equal to x. Finally, 10xy to the 4 plus 3. So this is fxy. And then I told you yx going to give you the same answer. So let's double check. So now, in this example, we already have f of y, and you're taking a second differentiation with respect to x. So first, we have to get fy, 5y to the 4, x to the 2nd plus 3x. Now you are taking d over dx. Are you following? So that's fyx. Which one is going to be c or whatever a? You can decide. I will say y to the 4. That's going to be your either c or whatever you want to say b. So I'm going to just say that is a equal to y to the 4. Okay. So now what happened? D over dx, 5a x to 2nd. Please do not include the number because we only look at the variable. So that's a 3x. So that is going to be 5 times 2, 10ax, and you're going to have a 3, right? Because we are taking the differentiation with respect to x. Now a is equal to y to the 4. So 10x, I can change the order. Y to the 4 plus 3. Dun, 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 dun. We just proved that they're equal. Okay, so always f second partial derivative between x and y, they're xy and yx, they're always equal to each other. So this is the second partial derivative work. Are you guys okay? So I'm gonna do one more example. That's it. That's a 4.3. I'm gonna wrap up. Can you show me your thumbs up? Does it make sense to you? So not only just one first partial derivative, but also chapter 4.3 introducing second partial derivative, like a second order partial derivative. And then that case, we have 4 different combinations, right? So this is only first partial, and then this is all the second partial. All right, so let me give you another example. So this was a simple question, right? We had a quadratic and linear, but as I mentioned, the function is keep changing. You never know. You might have an exponential, trigonometric, and then how are we gonna do that? So we need to practice. I'm gonna show you another function. So they're same question. Ooh, second partial. So and then, oopsie, we have, you see that? A little complicated function, but we know what's happening. Step 1. So this is one last example of 4.3. You need to first the partial derivative. So dx, what is a question? xe, negative 3y plus sine 2x minus 5y. So you're gonna take the first the partial derivative with respect to x. So what is going on? We're gonna take the derivative, right? So again, when you're looking at x, y will be the constant, correct? So we know that this guy is gonna be constant, and then x is gonna be 1. So it's the first term anyway, e to the negative 3y remaining only. Same thing like d over 2x, it's a 2. You can consider this as a constant because there's no x, there's only y. So there is going to be e to the negative 3y. Okay, the next one, I see the chain rule. So sine function and 2x minus 5y linear function. So sine will be cosine, right? So cosine outside, and then inside, chain rule, chain rule, chain rule. So that would be e to the negative 3y cosine 2x minus 5y. And then y is going to be the 0 because that's a constant. We have only 2. So again, if I rewrite it, e to the negative 3y plus 2 cosine 2x minus 5y. So far, that is my f partial derivative with respect to x. Okay, let's do fy. Fy. So d, or you could do faster than me. I'm just doing all the work. So x e to the negative 3y sine 2x minus 5y. There we go. All right, so we are going to take the partial derivative with respect to y. So what are you guys going to do? Now, x is the constant, isn't it? So x is the constant. So what else? What else are we going to do? Let me see. Anybody has a thought? What we're going to do? We are going to, with respect to y, so I think it is going to be -5 somewhere. I see that. What do you guys think? How are we going to take the derivative of the first term? X times e to the negative 3y. So in this time, x is the constant, isn't it? X is the constant. So what can we do? Anybody has an idea? What we're going to do here? We have a couple things we need to do. Oh, not this color. So we have x is a stay there because that's a constant. It's not going to be 0 because it's next to the e to the negative 3y. And then a little bit of long memory. Do you remember d over dx e to the x? It is e to the x. But d over dx e to the nx. So I remember UN show us that work. If I'm correct, that is going to be n e to the nx. Am I correct though? Yes, that's what's happening. So we are going to say n is a negative 3. So it is going to be x stays there. And then I have a negative 3 bring up e to the negative 3 y keep there. Are you okay? So make sure this is important work. I took the differentiation. I'm going to change the order later. And the next term, keep on going. it's going to be plus cosine 2x minus 5y, and then you're going to take the inside chain rule dy, 2x minus 5y. So in other words, if I change that order, negative 3x e to the negative 3y plus, what happened? This part will be negative 5. Am I correct? So negative 5. So I'm going to bring negative 5 here. So we have negative 5, or if you don't want to, I'm going to write it everything. Minus 5, and here negative 5. So that's going to be negative 3x e to the negative 3y. And then minus 5 cosine 2x minus 5y. Yes, this is the partial derivative with respect to y. So far, we only took the first, order of the partial derivative. Now we're gonna do the next one, xx, xy, yx, xy. So step by one, step by. All right, so the first one, I'm gonna do fxx. So d over dx, we already know what the f of x, e to the negative 3y, 2 cosine 2x minus 5y. Okay, so e to the negative 3y, that's actually now look like constant, isn't it? So that's going to be 0. Are you following with me? Because this is a dx. This is the constant. Everything is, there's no x variable, only y variable. That's, you can consider constant, and now it's going to be 0. So 0 plus 2. What is the derivative of the cosine? Derivative of cosine, that is going to be negative sine and 2x minus 5y. And I have inside chain rule 2x minus 5y. So therefore, 0 and negative 2 sine 2x minus 5y. And then you're taking only x too, because negative 5y will be 0. So finally, negative 4 sine 2x minus 5y. Beautiful. This is the second order of the partial derivative with respect to x. One more time. This is the second order of partial derivatives with respect to x. So this is fxx. Okay, three more to go. The yy. So the second one, yy, so d dy. Where's my fy? Right there. So negative 3x e to the negative 3y minus 5 cosine 2x minus 5y. There we go. Okay. All right, so what we're gonna do? We're gonna do step by step. I see a y there, and 3x is gonna be constant. So this is gonna be constant. And here we're gonna apply this rule. So step by step, 3x there, and I'm bring, oopsie. And then negative 3, bring it up, e to the negative 3, y, keep there, right? That's how you take the n, e to the nx. And then now cosine will be what? Sine, positive sign. So minus 5 sine 2x minus 5y inside 2x minus 5y. Can you double check? Am I correct? The derivative of the cosine is a positive sign or a negative sign? Somebody can check with me.
Negative.
Yeah, so negative. So I just knew that. So I have to have, so actually double negative, but for your information, I will write that for you. So negative. Okay, so that's better. So there's a dot means multiplication. So that's a better. And now, so there's a high possibility to make a mistake. So you have to really write down all the work step by step. So double negative now, change in positive 9, x e to the negative 3y. Double negative again, plus 5 sine 2x minus 5y. And what happened here inside? This is a dy. We have only negative 5. All right, 9x e to the negative 3y minus 25, because 5 times negative 5, sine 2x minus 5y. Beautiful, we got it. This is the second order of the partial derivative with respect to y. We got it. All right, 2 more. fxy, and you're gonna do fyx. Am I correct? So let's do it. Let's do it. So first, that means you already have f of x. Where are you? Right there. So you already have e to the negative 3y 2 cosine 2x minus 5. So this is f of y. I'm going to take the derivative of dy. Good. So what's happening? This is the y variable. I see the same y variable. So we just take the negative 3 e to the negative 3y. Okay, okay. And then what happened? Cosine will be what? Negative. So we have a 2. I have a negative sign. 2x minus 5y inside dy. 2x minus 5y. Beautiful. Actually, I don't need this one. One parenthesis. So negative 3 e to the negative 3y. We have a 2, actually negative 2 because of the negative. So negative 2 sine 2x minus 5y and negative 5. So what the answer? Negative 3 e to the negative 3y, double negative, positive. Sine 2x minus 5y. We got it. So that's the f partial derivative xy. And I told you they're going to be the same answer, but let's double check. We already have a y, so where's y? So y already negative 3x e to the negative 3y minus 5 cosine 2x minus 5y. Are you following? And here, this is a fy, and we are taking the d over dx, the second order. All right, so I just see the x. So now this is the constant. So you're going to keep it as a constant. So that's going to be negative 3. And you're going to keep it e to the negative 3y. That's a constant. So this one only negative 3. And then this one is a constant. You're going to keep the same thing. And then cosine will be what? Cosine is going to, if you take the derivative of the cosine, somebody can tell me it's a positive sign or a negative sign? Negative sign? Yeah?
You mean derivative of cosine?
Yeah,
Negative.
there we go. Negative sign, and we keep the 2x minus 5y inside dx, 2x minus 5y. Am I right? So now negative 3 e to the negative 3y minus 5. And this is double negative positive. Sine 2x minus 5y. And dx, it's going to be 0, only 2. So negative 3 e to the negative 3y, 5 times 2, positive 10 sine 2x minus 5y. So what happened? We have the same answer. So we just proved that fxy is still equal to yx. Okay, so that's all the second order of the partial derivative. So I show you 2 examples. So definitely there are more practice in our quizzes. You can practice more. Also, there are embedded video. You can do more practice if you need. Okay, but actually, that's the all about 4.3. So we finish it 4.3. And I have 2 more examples, but you can try it. Try those 2. So same thing. Step 1, find. I think this is a very similar what we did. And then you guys know what the ln. derivative of ln x, it is going to be 1 over x, keep in mind. So you can apply to there when you take the differentiation. So check it out, find out fx, fy, xx, yy, and then prove xy equal to yx. So definitely you can practice those two questions. Okay, check. So we finished 4.3. All right, good job. I'm gonna move on 4.4 anyway. Anybody has a question so far? Are you happy? Are you
I
okay?
have one.
Yes.
Why don't you use A, B, C, D this time than the previous example?
You can do that too. So that's, I just show you different approach. It's gonna be the same answer because anyway, you can have AB that's still considered as a constant. So if you go up, where was it? Yeah, you can still use the same approach. The reason why I use ABCD here, I just wanna make whatever the opposite variable as a constant because that's easier when you're taking the differentiation. But if you don't need this approach, if you can directly, take the differentiation, we've been practicing. So I just show you two different ways. Some people like this method because they can see exactly where the constants are. And that it helps us to find out the better differentiation, right? But if you don't need this, doesn't matter. You can directly keep on going, taking the differentiation. Does it make sense, Yuan?
Yeah.
So you can do either way. They're gonna give you the same answer. But I wanted to show you guys a two different approach so you can choose whatever you want. Okay. So usually textbook, they're using this method, but actually it's a double work, isn't it? But you can take the direct, work. So it's up to you. So I show you anyway, two different way. So catch up. So here, same thing. You don't need A, B, C, D. You can directly, take the differentiation. So it's going to be the same answer. All right.